In this video, I'll give you some tips for solving the ALEKS problem called drawing Lewis structures for simple organic compounds. I want to start by saying that the tips that I'm going to give you are ones that apply to drawing Lewis structures for organic compounds exclusively. These tips are not going to work well for other types of compounds. What are organic compounds? They're compounds that contain mostly carbon and hydrogen atoms with maybe some other atoms thrown in there as well. So the first thing that we're going to do is think about typical bonding patterns for atoms that show up in organic compounds. In organic compounds, we see a lot of carbon atoms. Carbon atoms typically like to bond with 4 single bonds, or two double bonds, or a triple bond with a single bond, or a double bond with 2 single bonds. So those are the common options that we're going to see for bonding around a carbon. We're also going to see hydrogen atoms in these molecules. They just bond in one way, and that is just a single bond. We're also going to see halogens, such as chlorine in my molecule. They also, like hydrogen, just form just one single bond. You're also going to see bromine, iodine, and fluorine in this problem as well. Also, same thing, just one single bond. You're also going to come across some oxygen atoms. Possibly oxygen atoms like to form 2 single bonds, and there's going to be some lone pairs on the oxygen, or oxygens like to form 1 double bond. Again, you're going to have some lone pairs, and I should put the lone pairs on these halogens as well. I looked at quite a few different versions of this ALEKS problem, and I didn't see anything other than these atoms, but it is possible that you might come across a nitrogen, like maybe I didn't see everything. Nitrogen likes to have 3 single bonds, or sometimes a triple bond, or nitrogen could have a double bond and a single bond. That's pretty unusual. So these are the atoms that you're going to come across when you're working on this problem, and these are going to be the common bonding patterns for those atoms. To start this out, what you're going to do is find your carbon atoms. You're going to have at least 2 carbon atoms in this molecule. You might have more. Take your carbon atoms and just connect all of them in a row with single bonds. Doesn't matter how many you have. Like if you had C4, you're just going to connect all of them. You're not going to put them into some kind of a loop. Just put them in a straight line. No matter how many carbon atoms you've got, put them all in a row, connecting them with single bonds. Now we may need to go back and change this to a double bond or a triple bond, but for starters, we're just going to go with a single bond. The next thing that you're going to do is, I'm not going to do it for this problem, but if you have an oxygen atom or if you had a nitrogen atom, that's going to be the next thing that you draw onto this Lewis structure. Now the ALEKS is going to tell you the bonding pattern for the oxygen atom. If it's an oxygen with a double bond, ALEKS is going to let you know because it's going to make some sort of reference to a carbonyl group. I didn't see anything other than carbonyl group, but it might say something like ketone, it might say something like aldehyde. So these are going to be tips that you're going to look for that'll let you know that the oxygen is going to be a double bond. And then if you have a single bond oxygen, ALEKS is going to say something like hydroxy or hydroxyl or hydroxide, some sort of variation of that. And so that, or it could maybe say alcohol. So you're going to look for that type of wording, and that's going to let you know what to do with the oxygen. Now, if you did have an oxygen atom, once you decided, based on the wording of the ALEKS problem, once you decided what type of bonding it was in, you're just going to throw that on the molecule. So let's just say that I did have an oxygen and ALEKS said something about carbonyl. I would just stick that oxygen on there, double bond it. It doesn't matter which carbon atom you put it on. You stick it on whichever one you want, and it's also not going to matter which way you point it. You stick it wherever you want. Honestly, I'm not even joking. You're just going to put it on there. Same kind of thing with the nitrogens. If you have nitrogens, and again, I didn't see any examples with nitrogens, but if you do, that's going to be your next step. So I'm just going to draw this out. So step number 1, we are going to do all of the carbon atoms, carbons, and you're going to connect them with just starting with single bonds. The next thing that you're going to do are any oxygens that you might have and any nitrogen that you might have. You're going to add that. And then once you get that done, you are going to add the hydrogen and any halogens that you might have. Hydrogens and halogens, that's the bromine, the chlorine, the iodine, etc. These guys, they only form 1 single bond. So the hydrogens and halogens are always going to be the things that you add last, and they're just added around the outside of the molecule. So I have 1 hydrogen and I have 1 chlorine, and I am going to just attach them let's just say I'm going to start off by doing it like that, looking like that. So there I am. Now the last thing that I'm going to do once I get all of that done is that I'm going to go back and I'm going to check my carbon atoms in terms of their bonding. So I have got a carbon atom on the left hand side, has 3 single bonds, and let's take a look at the common bonding patterns for carbon. That is not an option for carbon. 3 single bonds is not an option for carbon. This carbon have only 1 single bond, and that also is not an option for that carbon. So that means that my structure is not done yet. I need to make some modifications to it. For my focusing back again on my carbon on the left, I have 3 single bonds. I could modify it to look like this, 2 single bonds and a double bond. Keep in mind that these single bonds are fixed because hydrogen can only form a single bond, chlorine can only form a single bond. I can't make a change there, but I could change my carbon on the left to match this sort of pattern by doing this. So now my carbon on the left has 2 single bonds and a double bond, and it matches up with this guy. So it's looking pretty good, but what about this one? This is a carbon with just a double bond, and again, that is not an option for carbon. Bummer. So if you come into this situation where you're like, there's just literally going to be nothing I can do to make this carbon happy, what you need to do is backtrack a little bit, and what I'm going to do is reposition the hydrogen and the chlorine. So instead of putting both the hydrogen and the chlorine on the same carbon atom, I'm going to spread them out over the 2 carbon atoms. I'm going to put the hydrogen on one and the chlorine on the other. And it's not going to matter which way I go with it. Honestly, it won't make a difference. Just put one on the first carbon and put the other on the second carbon. So now my carbon on the left has 2 single bonds, not an option for carbon. Remember, I can't change this to a multiple bond. This has got to stay a single bond. I can't come up with a couple more bonds. I can't come up with even more bonds. What if I did something like this? 1 single bond and a triple bond. Take a look at that. So if I do that, my carbon on the left has a single and a triple. That's good. My carbon on the right also has a single and a triple. That's good. My hydrogen, single bond. My chlorine, single bond. Everything looks perfect, almost perfect. I need to make sure to include my lone pairs. I don't want to forget that. And that is my Lewis structure. ALEKS maybe isn't going to let you draw it like that. It might want to force you to position these bonds in a particular angle, but that's no big deal, because if that's the case, you would be forced to draw it in that way. So this type of problem might involve a little bit of guess and check, a little bit of back and forth, but as long as you're following these bonding patterns, paying attention to any tips that ALEKS gives you about the way that you should be drawing your oxygen atoms in your structure, you should be good to go.